All right, this video I'll be going over comparing bits and pieces 1.3 and 1.4. You may need to pause it to get the notes. There's not too much in this one. All right, so equivalent fractions. Equivalent fractions are fractions that are equal in value. For instance, 7 over 1 is the same thing as 7, right? But they may have different numerators and different denominators. So 2/3 is equivalent to 14/21, and I'm going to show you how. So if I shade 2 out of every 3, we've got 21 squares here, 3 by 7. If I shade 2 out of every 3 of these, I've shaded 2 out of every 3. I have shaded 14 out of the 21. Okay, that makes them equivalent fractions. We're going to flip over and look at page 16. We are going to skip A2 and B1, and we're going to start with B2. It says the picture below shows the students' halves, fourths, and eighths strips. How does the size of one part of halves compare to the size of one part of the eighth strip? So if I look at half, if I just look at one piece, how many pieces do you see on the eighth strip? So 1/2 is equal to how many eighths? It's equal to 4 of the 8, right? So that makes them equivalent fractions. 3. What fraction strip can you make if you start with third strips? We are going to skip this because we are actually not going to make the strips this year. So mainly I just wanted you to be able to compare this. So if you look at halves, how many fourths do you see that is equal to a half? You have 2/4 and you have 4/8. And that's really all I wanted you to see on this, is that you can compare them. So if we look over here, this is at the bottom of your paper. C says, in earlier grades you used number lines such as the one below to show whole numbers. So you looked at something like this. Now you can use fraction strips to mark points between whole numbers. You start by using a fraction strip to mark and label 0 and 1. Some students began to make a number line using their 1/3, 1/6, 1/9, and 1/12 fraction strips. The drawing shows their work so far. One student used the top fraction strip to mark 2/3 on the number line. All right, so they have marked 2/3 right here. And if we look at this one, how many pieces? This is 1, 2, 3 pieces, so there's a total of 3. 1, 2, 3, 4, 5, 6 pieces, so this is a 6th piece. 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice that I'm counting the spaces and not the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I just counted up how many pieces it was broken into. So if I'm going to try to compare fractions and I bring this line down, I can see everything that 2/3 is equivalent to. So at this line I'm at on sixths, 1/6, 2/6, 3/6. This is the 4/6 line. So 4/6 is the same thing as 2/3. Here I am at the ninths. 1, 2, 3, 4, 5, 6 ninths. 6 ninths is the same thing as 2/3. Coming down to 12. 1, 2, 3, 4, 5, 6, 7, 8. 8/12 is the same thing as 2/3. B, name another equivalent fraction to 2/3. So can you think of anything else that would have an equivalent fraction to 2/3? So let's look at one of the ones we found. Let's look at this. How would you get from 3 to 9? You would multiply by 3. How would you get from 2 to 6? You'd multiply by 3. So didn't we just do 3 times 3 is 9 and 2 times 3 is 6? So couldn't we take a fraction and multiply by any number we wanted to, as long as we multiply the top and the bottom by that same number, and get an equivalent fraction? So you could choose any number you would like. I chose 10. All right, we are going to move on to 1.4. 1.4. Ratio comparisons. For every $60 the sixth graders raise, the seventh graders raise 90. Okay, this is for every, it's a ratio comparison. Fraction comparison is when the sixth graders meet their goal, they will have raised 2/3 of the seventh grade goal. So again, we have a fraction in there, making it a fraction comparison. All right, we are moving on to 1.4. Here are two claims about the fundraising goal from problem 1.1. For every $60 the sixth graders plan to raise, the seventh graders plan to raise 90. We already agreed that that was correct. When the sixth graders meet their goal, they will have raised 2/3 of the seventh grade goal. We've already agreed that that's correct. Ben and Kimmy are each comparing one sixth grade goal to one seventh grade goal. Ben uses ratio to make comparisons and Kimmy uses fractions to make comparisons. Think about some ways in which working with fractions is like and not like working with ratios. So remember, with fractions and ratios, the ratio can be written as a fraction, or it can be written with the word two, or with a colon. When you use fractions to compare a part to a whole, you often have more than one fraction name for the same quantity. For example, in problem 1.3, you found that 1/5 is the same as 2/10. In the next problem, you will compare the fundraising progress of a grade and its fundraising goal using fractions. So in this case, what number did we multiply? We multiplied 5 by 2 and 1 times 2 and ended up with 2/10, right? The thermometers on the next page show the progress of the sixth grade poster sales after 2, 4, 6, 8, and 10 days. The principal needs to know what fraction of the goal the sixth grade has achieved after each day. How can you use fraction strips to measure the sixth grade's progress? All right. So on this one, all right, for this one, we're going to go ahead and flip to page 22. It says examine the thermometers on the previous page and your fraction strips, which you should have gotten. Looks like this. How can you tell whether the sixth grade raises the same amount of money each day? So here's day 2, here's day 4, 6, 8, and 10. How could I tell if we're raising the same amount of money each day? Well, to me, I would look and see if they're going up by the same amount each time, right? So you can put that in for A. We could use the bars to see if they go up by the same amount each time. So let's look at this. Do these bars look like they go up by the same amount each time? Well, I can look at this and say, no, they don't. But if you couldn't, you could just get a little sheet of paper and say, okay, it grew this much from here to here. Now, if we put that at the same level, did we grow that same amount? Clearly, we did not grow that same amount the next day. So, day 2. Let's see, the question says for B. What fraction of their goal did the sixth graders reach after day 2, 4, 6, and 8? Okay, so we can go back to our thermometers. And so I'm trying to figure out what fraction of the entire bar the blue piece is. So what I've got to do, all of my bars, they are the right height. They're about as close as I could get them to be of the bar, okay? So I'm looking for one that the line would be right here. So if I follow this across, it looks like fourths. So I'm going to fold my paper and see if that fourths is very close. Yes, it looks like it's about 1/4 of the whole goal. So I'm going to write that into my packet. The fraction of the goal met after day 2 was 1/4. How about this goal? Here we go. We have the whole goal. Did the fourths line up? It's not fourths. Let's line it up and kind of go across. It looks like it could be thirds. So let's look at thirds. I'm going to fold my paper so the thirds are right there on the edge. Kind of tedious work, but it's better than cutting these out because it makes a big mess. All right, thirds. And to me, that looks like it's exactly a third. So after day 4, they had met a third of their goal. Day 6, I need to find a fraction that's about equivalent. I need to line up this. And it looks like it could be maybe either tenths or twelfths, somewhere over here. So let's look a little closer at the tenths. Nope, not tenths. Let's look at ninths. And to me, that looks like it lines up perfectly. 1, 2, 3, 4, 5 ninths. Looks like they've reached about 5 ninths of their goal. After day 8, let's line it up. Okay, let's line it up at the very beginning so I can kind of get an idea of what I need to look at. It looks like it's pretty close to that one. Let's look at fourths again. To me, that looks like it's exactly 3/4. 3/4 of the goal. And after day 10, that looks like it could be let's see, we could look at sixths. Maybe it's a sixth. Line it up very carefully. Yep, it looks like it's 5/6. So after day 10, they had reached 5/6 of their goal. And let's move on to C. Let's see what C says. Mary used her fourth strips to measure the label, fractions, and dollar amounts on day 2, thermometer at the right. So here she did 1/4, 2/4, 3/4, 4/4. Did she write the correct dollar amounts? How do you know? So if we're breaking it into 4, we need to break 300 into 4. And if we divide 300 divided by 4, each one should be worth $75. So she did do that correct. And I know because there's 4 pieces, and the 4 pieces are the same amount, and they add up to 300. And we are going to skip C2. And I think we are done for today. We will go ahead and get the 1.5 notes in so that we don't have to write them next class. We will pick up on 1.5 and we will go back and review everything from today when I return next week. So your tape diagram kind of looks like this. You have your for every statements. You have a ratio statement, starts with the word the ratio. And then you also have another ratio statement. Remember the difference is this one has the word to, this one has an actual colon in there. Technically there is a third way to write that, and you could write the 60 over the 90. So get these into your notes and then you should be done for the day. You may move on to prodigy.com or work on your Compass Learning.